problem we had on the board?
0.98.
98.98. We're trying to answer this question. The grams, they gave it to us. They said there was 1.2 grams. We need to calculate moles. And whenever you're calculating moles, and it's a gas, you're going to rearrange this formula PV equals nRT. I didn't get to it, it's in your reading. I'll get to it on Tuesday, but 1 mole of any gas at STP will try to occupy 22 liters. So the minute I saw this 1 liter, I knew we have to come up with a very small number of moles. So if we take 0.98 divided by 0.0821 and then divide it again by 293, we come up with what for a number of moles? It's got to be less than 1. 0 what?
0.04.
0.0407 moles. If we stop for just a second, what's the lightest chemical we've got?
Helium?
There's a lighter one than helium.
Hydrogen.
Hydrogen. We have no chemicals lighter than hydrogen. What's its molar mass?
1.01 or 0.001.
Excuse me?
1 mole.
No. Hydrogen's diatomic. So the minute they ask you, come up with the molar mass of this substance, the answer has to be greater than 2, because that's hydrogen. The molar mass of any substance is from its chemical weight, and the lightest one we've got is hydrogen, and hydrogen's diatomic. So when we get done with this answer here, it's got to be bigger than 2, or 2 or bigger. So here's our grams. This is the number of moles we have captured. This number had better be bigger than 2. 2 sig, I don't know, how many does the key say? 2 or 3 sig figs, what do you get?
99.48.
29?
0.48. How many figs?
Grams per mole. $29 roughly. What does the key say?
That was omit.
Oh, it doesn't, okay. In the back where it's all, they're all worked out, there is an answer for that one too. So 29 is a legitimate answer. We have to have a molar mass greater than 2. I'm sorry. I feel like I'm rushed, and I know you feel the same, but we can't do anything about it. I'm gonna try to make your life a little bit easier by saying that you don't have to memorize these formulas, but at the same time, you need to know them for Metro's final. Well, will they give us one? They get to do all sorts of, making you do all sorts of conversions by giving you one of these. So, yeah, I think so. As you're gonna find out, you can't get it done in 5 to 6 minutes. So I don't think this lab is gonna show up anywhere on your 16 questions for next Thursday. But it sure can show up on your written final. Okay, I would now like to talk about the lab. So would you take the lab out, please? It's the lab on butane. I'm not sure of this number. Do you have the number of it?
34.
What?
2.9.
Okay, we're all like looking at it.
It's
Oh,
because-
what's going on?
That's because I didn't put the moles up here right, did I?
Oh, okay, that makes more sense.
So that would move the decimal point over to 29. You have the lab out?
Not yet.
Hurry. Inside this container is trapped butane gas. You are to come up with the molecular weight of butane gas. So you need to have what two numbers to come up with the molecular weight?
The grams and
The grams and the
moles.
moles. So what we're gonna do is you're gonna weigh this before, and then you're gonna let some out and weigh it again. So that will be where you'll get your mass from. To get the moles, you need to trap a gas, and you need to know its pressure, you need to know its volume, and you need to know its temperature. So that's what this apparatus that they have set up for you is: a water bath where you can trap the gas. Okay, the substance is butane. I would like you to calculate what, according to paper, on paper, what is the molar mass of butane? And I would like it to 4 sig figs, and I would like us all to agree upon it. When somebody has a weight, would you let me know what you come up with? And then I'll post it, and we'll see if we agree upon it.
58.14.
Sounds pretty good to me, that's in the ballpark. We have agreement? Okay, would you go to page 381? And in line 13, would you put this number in there? Sorry, my mistake. This is on paper, so this is the theoretical. Line 15. Would you cross out line 14? I don't want you to take the two and add them together and come up with the average. I want you to give me 2 accuracies. I'm going to grade you off your best one. So, to tell when this container is full of butane, what you're going to do is you're going to put it into the water and submerge it and get all the air bubbles out. And when you tip it up, it should be full of water. I did a poor job. That's because nobody at this table was trying to help me. You're gonna have to work on it a little bit because you've got to get it just right so you have no air bubbles in there at all. And then you can grab a clamp out of your, or should be, grab a clamp out of your drawer so that you can hold it up so that you can put your hand underneath it. Okay? Don't start looking for a bunch of stuff, I understand. I'm really trying to help you. All right? We have a couple problems because we're catching this over water and water evaporates. So the first thing I need to give you is line 7. Would you look at line 7? It wants to know what the barometric pressure is today. Would you put in there 30.03 inches?
For both the trials?
Yes. Would you now take the temperature of your water, put your your thermometer into the water and let it set for a few minutes. Oh. These are cheap thermometers. The real nice, expensive ones are made with mercury, but mercury is a problem. So would you take a look at that thermometer and see if it has any air bubbles in it? Is the fluid congruent all the way through? It won't tip or anything. Then you can go ahead and put it in so it measures properly. Sometimes these alcohol thermometers get air bubbles in and they don't read properly. We need to come up with the temperature of the hydrogen. Oops, sorry, we're not catching hydrogen. The temperature of the butane, the volume of the butane, the pressure of the butane. First thing we will need to do is to convert this into millimeters of mercury. Would you do that right now? At your table, convert inches of mercury into millimeters of mercury. 1 atmosphere is equal to 760 millimeters of mercury, which is equal to 29.92 inches of mercury, which is equal to 760 torr. We need to convert it into millimeters of mercury. Four sig figs. Whoop. Not atmospheres yet. The next line underneath it does say millimeters of mercury, does it not?
Yeah.
I've given you line 7, we have to calculate line A. To 4 sig figs, it comes up to be what number?
762.8.
762.8 millimeters of mercury. When you got the butane in here, you can record the volume of it off the graduated cylinder. You're gonna put your hand underneath. This is my butane lighter. You're gonna put it underneath. The bubbles will go up and it will push the water level down. And in your reading, they tell you to do something about that water level before you make all the readings. we have a problem. Water evaporates. So this is the pressure of the day. And when we get the water levels equal, the gases that are trapped in here will equal the pressure of the day. But we have water in here. So in line 9, it says that you are to look up the water vapor pressure. And then you are to subtract it. So right there on line 9, would you put that you are going to subtract it out from line 8? Line 8 minus line 9 will get you line 10. On page 443, you have the vapor pressure for water. In your lab book on page 440, was it 443? 433, sorry. I don't know why Metro does this to you. Here's the pressure, depending upon what the temperature of the water is. The pressure is measured in torrs. You have your pencil handy? 760 millimeters of mercury is equal to 760 torr. They're the same. So up there where it says torr, put a line through it and put millimeters of mercury. They're equal. Would you now look at the temperature of your water? You and your lab partner. Oh, this is a good lab question. What's the temperature of your water to the correct number of sig figs? Very good. It should be to 1 point past the decimal. Yours might not match hers. Take what yours is. 20.0, go ahead and fill it in. Which line is it in your data table? You might need to double check it, because with your hot little hand in there, it might warm it up for trial 2. Would you now look up what the pressure is for water at your temperature? Where it says water vapor pressure, which is line what? 9? You can go ahead and subtract take line 8, subtract line 9 from it. You are to remove the water vapor pressure. So take line 8, which you already have, subtract line 9 from it.
ground to four sig figs, since that's what's in line 8?
Yes.
745.3.
Line 8, sorry, line 10 now is the pressure of your butane. So you need to convert that to atmospheres
11,
to make line 11. Yep.
so, 745 divided by 17.
Mm-hmm. So convert line 10 into line 11 by using the conversion. 1 atmosphere is equal to 760.
How many sig figs you
4, I think, no more than that. Don't you have 4 before you do the subtraction?
You get 0.9805. 1 atmosphere is worth 760 millimeters of mercury, so 745 divided by 760.
Oh, I did it the other way around. I did right next to it.
You
Okay,
said-
could I have your attention for just a couple more and then I will turn you loose. You need to record your data for 1 through 7, I believe it is. Oh, 6. Once you have 1 through 6 recorded, you can go ahead and start on trial 2. And that just means you're gonna dump out the butane and refill it. Okay, this lab works great, but it has one critical spot. 20 drops of water make 1 gram. You're not gonna come close to getting 1 gram of butane out here. 1 drop of water is about 15% error. So when I weigh this dry, and then I stick it underneath and turn the valve and let it bubble out and then bring it out, it's gonna be loaded with water. Each drop of water is 15% error in your lab. Dry this off real well. They should have a hair dryer. Weigh it, and then I would dry it off 2 more times or to weigh it. Once that weight becomes consistent, you can feel pretty good that you got all the water out of there. And there's all kinds of nooks and crannies for the water to hide in. It should be considerably less it should be much less than 1/2 of a gram. If you've got 1.5 grams that you let out, you've got all kinds of water dropped in there. So dry it off 2 or 3 times to get the weight to stay the same. And then you can go ahead and start on trial 2. Okay? I'm not done. You asked me to do some homework, so I did. I took this sheet and I put some side comments over here. I've already given you this sheet once. I put mine in different print, saying, this is where I think they can come at you to ask you about your 16 questions. The one we're doing today requires too much time. There isn't any way they can ask you to do it. The one that we're gonna do on Tuesday also requires too much time to do. They're going to get their 16 questions from these parts in here. I have a pre-test 5 for you to pick up before you leave, or you can pick it up on Tuesday. I have nothing else to mention, you can go ahead and get on to the lab.